Okay. Hello, hello. One, two, three. Mic check. We should be live right now, and we are live. Okay, perfect. We'll wait for a few seconds here and there just to confirm that. Okay, everything's fine. We will be using the live chat just to make sure everything is cool. We have someone who's freaking Astra, and that person is saying hello. So, hello. I have no idea who you are. Uh, but hey, hello. Cool. Good for you. Welcome to the channel. There's also Atharva. Atharva has been waiting since like an hour, I feel like at this point. So, hi, Atharva. Thank you for waiting. Oh, you're Rudra. Rudra, why do you keep on changing your, I don't know, name? Sunny is here, Veer is here. Okay, that's cool. We have the gang, most of it. That's fair enough. Low voice, again? Really? I doubt it. Am I? Okay. Guys, check, mic check. Is this really low voice? Because I'm pretty sure this is like high voice. You're from Bangladesh. Good. Fair enough. Hi. But okay, the voice should be fine because I think I'm maxing out on my recording thingy. Also, I do not I don't have, and yeah, voice isolation is on. It should be fine, guys. It should be fine. Yeah, cool. Okay, fair enough. We're gonna start. We'll start with, I mean, so I have three topics over here. I mean, I have like two more bonus ones. I didn't like get much time to actually, put it up here. But we will actually talk about load balancing, and then we'll kind of jump on onto other things. So let's do that. Let's do that. But before that, how's your weekend going? And also, this time we are doing live on Friday instead of Saturday, is because tomorrow is, I believe, the final match, and I did not want to compete with that because I myself probably would be watching the match. So, hey, who knows, whatever. But yeah, we have 11 people. That's a lot, whatever. Okay, first things first, we will start with load balancing. This is the topic that we wanted to kind of do. And so we are starting with this. We will talk about the recent hacks that have been going on. We'll talk about that. There's like a proper blog post that we'll have to see, we'll have to follow. We'll get there when we get there. At the moment, this is what we are doing. So buckle up, grab your snacks, whatever. This is what you're doing. Okay. Now, let's actually take the chat out, and let's try to put it somewhere else. So let's just move it to live and put it next to load balancing. Okay, now I can see the chat as well as everything that's going on. Cool. Okay. This entire article, by the way, it's about load balancing. This is like a really good one. I really prefer it. It actually kind of gives you an intuitive understanding about what is load balancing, how it actually works. Because last time we were talking about DDoS attacks, and then I kind of mentioned that you would have some sort of a load balancing device. A lot of people were interested in knowing what exactly that would be, and so this is what we'll be doing now. Past a certain point, web applications outgrow a single server deployment. Companies either want to increase their availability, scalability, or both, right? To do this, they deploy their application across multiple servers with a load balancer in front to distribute incoming requests. Big companies may need thousands of servers running their web application to handle the load. Now, this is kind of very obvious. Any company you take, for example, if you take Flipkart, Amazon, Zomato, whatever, at after a certain point they might have enough users that a single server won't cut it. Now you can make that single server very powerful, right? It can have the best of internet, but you will still hit limits. It would make sense to, instead of having one single super powerful server, to have two medium level servers, so you can now actually balance the request, right? And it's also not just about who has the fastest internet or who has the highest bandwidth, but sometimes it's about how do you divide the request. Sometimes you will reach physical limits first. Okay, so in this post, we are going to focus on ways that a single load balancer might distribute HTTP requests to a set of servers. We'll start from the bottom and work our way up to modern load balancing systems. Okay, so that's what we're going to do. It's going to be fun. Okay, let's just go. Let's start with our visualization. So if you can see, yeah, there's a very pretty visualization over here. Hopefully you guys can see it. Let's start at the beginning. A single load balancer sending requests to a single server. Requests are being sent at the rate of one request per second, or RPS. From now on, we'll be referring it to RPS. And each request reduces in size as the server processes it. So you can see here that, hey, this is like probably like the client, and they're sending a request to this server. Like they're sending specifically a request. And once the circle goes down, that's the processing happening. So once the circle is gone, that green circle, the process is done, you can handle a next request. Okay, so this is what is basically happening in the backend. Now, for a lot of websites, this setup works just fine. Modern servers are powerful and can handle a lot of requests. But what happens when they can't keep up? So here you can see in this example, what happens is the client is throwing a request, but while the server is trying to process, there's another request. And the red balls that you see falling down, those are dropped requests, right? Like that's when the server cannot handle any more requests. And so those requests are just dropped. And I mean, we might actually see this in our real life every single time we actually, reload a web page, or every single time we try to visit a specific website. A lot of our requests are actually dropped, but we are comfortable because we just retry and usually it just works, right? Here we can see that at a rate of 3 RPS causes some requests to get dropped. If a request arrives at a server while another request is being processed, the server will drop it, which seems fair, right? This will result in an error being shown to the user, and is something we want to avoid, right? So you usually get an error, you just refresh, it just works fine, right? We can add another server for our load balancer to fix this. So yeah, that's a more updated mechanism, right? So you have a client, and then you have two servers, and it alternates between those two servers, and that's it. That's our load balancer, right? Fair enough. Hopefully everyone is okay. I hope everyone is making sense of this. Okay. Cool. No more drop requests. The way our load balancer is behaving here, sending a request to each server in turn, is called round robin. Now, hopefully, guys, if you learned OS from me, you would know what round robin stands for. You go around one by one in a circle, well, in a specific round robin scenario, and you're sending requests to all of them time by time by time. It's one of the most simplest forms of load balancing, and it works well when your servers are all equally powerful and your requests are all equally expensive. Expensive meaning that it's going to take the exact same amount of time for all the requests to get loaded. But in reality, this is not how it works. Okay. Now, let's talk about when round robin. Once again, you guys can see is the requests are going to all the servers one by one, and they're just, just working fine. Now, when round robin doesn't cut it. In real world, it's rare for servers to be equally powerful and requests to be equally expensive. If you use the exact same server hardware, performance may still differ. Applications may have to service many different types of requests, and these will likely have different performance characteristics. Let's see what happens when you vary request cost. In the following simulation, requests aren't equally expensive. You'll be able to see this by some requests taking longer to shrink than others. So you can see, for example, this specific server is always taking a lot of time to actually, try to figure out. And you can see sometimes some requests are, getting dropped randomly. So this seems like if you're using round robin, and if the request size is different, like maybe they are more expensive, maybe they are like bigger requests, you will drop packets, right? Once again, round robin doesn't cut it. We'll have to come up with some better option. Okay. So far, people in the chat, what do you think? You can, I mean, you guys can just keep on typing. That's okay as well. If you like at this point, what suggestion would you have? What different type of metric would you bring? What idea would you bring here that we can change the way load balancing is working? For example, my idea would be to maybe send requests to only the servers which are done processing. Maybe a certain time a server is done processing very quickly. Send the request instead of going one by one. Just spam them with requests, right? Priority request, fair enough. Okay. I'm assuming you, uh, Ned Stark, I believe you might have read this article before. I don't know. What you might say is you might send a specific request which is like higher priority, and so that is supposed to be taken first. Sure, but what else? What else can be done? I hope you guys are coming up with ideas because I'm gonna, kind of move on. So while most requests get served successfully, we do drop some. One of the ways we can mitigate this is to have a request queue. So this is what is happening. What we'll do is we'll send the request to a server. And if the server is busy, we just put it in the queue. So we have a request queue. Okay. And hopefully you guys can see the queues are always, it's kind of fine. You can always just put extra in the queue. But sometimes what will happen is some queues will reach till like 2. And sometimes if you are very unlucky, it might reach till like 3, right? But if the queue is full, then the requests are still getting dropped, right? This is what might happen. Okay. Now request queues help us deal with uncertainty, but it's a trade-off. We will drop fewer requests, but at the cost of some requests having a higher latency. If you watch the above simulation long enough, you might notice the requests suddenly change color. The longer they go without being served, the more their color will change. You'll also notice that thanks to request cost variance, servers start to exhibit an imbalance. Queues will get backed up on servers that get unlucky and have to serve multiple expensive requests in a row. If a queue is full, you will drop the request. You can see that actually happens. So if let's say a request is in queue for a longer time, that has a very high latency. That probably means the user, whoever sent that request has to wait for a longer time. You can see in this specific one, it just gets unlucky and yeah, we just dropped the request. I don't know if you guys saw that in like the first two, second and third server. That might happen as well. So this is not a perfect solution, but it's kind of a decent one, right? Now, everything said above applies equally to servers that vary in power. In next simulation, we also vary the power of each server, which is represented visually with a darker shade of gray. So I want you to look at this animation. So the darker colored servers, they are more powerful compared to the lighter colored ones. And if you are using round robin, we can see the first server is always going to drop requests, right? And there are some servers who have been in the latency, like they have like the highest latency because they are stuck in a line for so long, right? So I want you guys to actually look at the diagram and actually try to make sense of it, because I believe it's a very beautiful diagram. Yeah. While you guys actually check that, I'm going to check my WhatsApp. You can prioritize the request with server capability. That's a good idea. Yeah, we can definitely do that depending on, maybe we can just send more requests to the server, which is more powerful compared to doing this. But right now it's fair. This is equal. It's not equity, but it's like kind of equality kind of thing. Also, can we also increase the resource of the server horizontally or vertically? What are you trying to say, Sunny? Could you explain? Well, what do you mean increase resources of the server horizontally or vertically? These are queues. These are queues. So if you're trying to say, can we increase the size of the queue? Yeah, we can. We can definitely increase the size of the queue. But the issue is, if we increase the size of the queue, there will be certain requests, especially for this first one. This one is just getting unlucky, right? People over here, look at this, like it keeps on changing to brown and brown and brown. Imagine you go to Amazon and you now have to wait for so long because you're stuck in this queue, right? Compared to this one, you just get your request very quickly. So maybe round robin isn't fair. It looks fair, it's equal to everyone, but it's not fair. It's not doing justice, you know. So the servers are given a random power value, but odds are some are less powerful than others and quickly start to drop requests. At the same time, the more powerful servers sit idly for the most time. As we can see, this server is just sitting idly for like the most of the time, more than half of the time. Despite its flaws, however, round robin is still the default HTTP load balancing method for Nginx. You guys must have heard of Nginx. That is what this is, right? That Nginx uses round robin internally for load balancing. Okay, let's improve on round robin. Let's you guys gave some ideas, and I'm pretty sure those ideas are actually inside this article as well. It's possible to tweak round robin to perform better with variance. There's an algorithm called the weighted round robin, which involves getting humans to tag each server with a weight that dictates how many requests to send it, right? In the simulation, we use each server's known power value as its weight, and we give more powerful servers more requests as we loop through them. So here you can see what's happening is the weaker servers, they don't get much requests. A bit more powerful one, they can actually get more requests. So you can see this one is getting a lot more requests, but sometimes it still can get unlucky and it can still drop packets, right? So that might happen. That is something that might happen. We can distribute the query or request according to the location so that it can distribute evenly. Okay. So when you have a load balancer, imagine these are the servers in the same server farm. They are in the same location. This is the load balancer. This black box, that is the load balancer. Already requests are coming to the load balancer, and then load balancer is deciding where it should go. They are already in the same location. So it does not make sense, to distribute according to the location. I hope that is making sense to you, Agam. All of them are in the same place. Okay, it's just load balancer. This is happening on server side already. Okay, I shouldn't have called this black box client before, but yeah, this is everything is happening on the server side. Horizontally adding more servers and vertically to increase its capability. Yes, Sunny, we can definitely do that, right? But as I said, if we increase the queue length, there will be people who get stuck in queue, and it will be a horrible experience for them. Sometimes it's just better to increase the servers, right? Can we send a drop request to other servers? No, Atharva. When I say we are dropping a request, we are not technically, letting it go. That drop request, it's just gone. We didn't reply back to it, right? So if I'm sending you a request, a drop request is like ignoring the request. Once that request is ignored, we can't send it somewhere. In fact, one might argue that's what we are doing. Like the first server can't handle requests, so we are sending it to second server. You are just describing load balancing, right? Well, technically you are describing a load balancer for the load balancer, but that's still the same thing. So yeah, hopefully that made sense to you guys. Okay, I'm gonna move ahead a bit. Okay, now, cool, 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 cool. Okay. A few important messages, but nothing too critical. Okay. While this handles the variance of the server power better than vanilla round robin, we still have request variants to contend with, because see, you'll still have requests which are more intensive, more expensive, right? So falls apart quickly. Boiling server performance down to a single number is hard, right? We cannot have weighted round robin explain everything, because that's just a single number. It does not make sense. Sometimes you need more complexity, right? So this is rarely done. So another variant of weighted round robin calculates weights dynamically by using a proxy metric, latency. Now we are going to flip. Okay, instead of calculating how many requests a server has, we will start talking about how much time a server takes for an average amount of requests, and we'll call that metric latency. Okay. If you notice, I just exchange it. Want you to form a team and we will work for you. Spy, I have no idea what you're talking about, but cool. Anyways, so it stands to reason that if one server serves three requests 3 times faster than the other server, it's probably 3 times faster as well, and should receive 3 times more requests than the other server, right? And which is what is happening. So instead of calculating a single weighted sum, what we'll do is every 2 times or every 3 times we go through the entire load balancer, we will calculate the average, and based on that average, we will send the number of requests the next time. So the weighted round robin is dynamically changing. Okay, so the weights are changing dynamically. That's basically it, more or less. Okay. Now, I added text to each server this time that shows the average latency of the last 3 requests. So it's actually doing 3 requests. So like 3 turns. We can decide whether to send 1, 2, or 3 requests to each server based on the relative differences in latencies. The result is very similar to the initial weighted round robin simulation, but there's no need to specify the weight of each server up front. This algorithm will also be able to adapt to changes in server performance over time. This is called a dynamic weighted round robin. Hopefully, it's making sense. Weighted but dynamic. Okay, so the weights are changing constantly. Let's see how it handles a complex situation with high variance in both server power and request cost. The following simulations uses randomized values. So feel free to refresh the page a few times and you can see like different values. So you can see the requests now have a very high variance in like request cost, like they are more expensive, they might be less expensive, it's random. And there's also a very high variance in what is the server power. Also, I hopefully you guys understand what is variance. Variance is usually calculated when you have, let's say, 10 different things, and then you take the mean of those things, like you find what is like the middle average, and then you find out how different are they from the average. That's what we mean by variance, kind of. Well, technically, to calculate variance, you would have to calculate standard deviation. There are square roots involved. It gets messy, but that is the most generalized like explanation. You take out the average, and then you find the difference for each and every you know whatever items there are. How different are they from average? That's their variance, right? So here, high variance would just means you have a random category. Instead of picking random numbers from 1 to 5, we are picking random numbers from 1 to 100. So you might have a lot of different, variable variance. It's kind of difficult to explain, but I hopefully you guys, figure out basic mathematics and statistics. So whatever. So here you can see it works fine. We are still using round robin because we are still doing this, right? This is still round robin, but it's just a combination. Zora, okay, cool. What I'm gonna do is let me just open up Z, and let's go through this. So for example, let's say you have um, 10 values. So let's just pick up 5, 7, 8, 9, 3, 45. Oh, that's a very big number. 11 should be fine. 12, and let's pick up 70. And let's also pick up one more, 16. Sure. Now, if you were to take an average out of all of these numbers, so let's try to calculate the average. So for example, I can just, okay, that wouldn't work. Let's just go online. Let's just search for it. Calculate average online. I am pretty confident I could have just written a Python. Okay, this is stupid. Can I not just like put numbers? Thank you. Do they have to be comma separated? I hope not. I hope this is correct. Uh, yeah, I mean, it says the count is 10, so whatever, who cares? Okay, so the sum is 92, which seems fine. So let's just total is 92. We had 10 items, right? So we have like what the total number of items. So I'll just write number of items is 10, right? Hopefully this is making sense to you, Zora, at this moment. So you have 92 items, 92 total, which is the sum. You have 10, and the average or the mean in this case. So if you find out the mean is 9.2, right? So if you take out the average of all these 10 values, you get 9.2, which is fine, which makes sense. Fair enough. Zora, I need verbal, not verbal, but yeah, cool. Okay. So now what I'm going to do is, once again, I'll ignore the median at the moment. We only care about average right now, right? There is geometric mean, there's also median, but I'm not going to get there. Okay. So as it says, the smallest is 3 here. So the smallest is 3. So we also want that information. Smallest is 3 and largest value is 70, right? So probably the range between both of them. So if I find out the range between both of them, it's just what? 14, right? So the range between both of them is 14. So like 17 minus 3, 14, right? So now you have 14 different places that your random number, if you were to pick something between 3 and 17, you have 14 different places you can pick something from, right? Now, how would the variance be calculated in this case? Well, it's very simple. You take 5, which is like the first thing, you subtract 9.2 out of it, and well, you try to take the only the positive side of it. So this will be like what, 4.2. Then you subtract 9.2 over here. Once again, I'm ignoring the negatives. Once again, minus 9.2. And this would be what, 1.2, 9.2 again. And hopefully you get the idea, right? So all of these values that we are seeing over here, they are basically what we call variance. Once again, this is not the exact definition of variance, but I want you to understand how far they are from the actual average values. And that's what we are trying to understand. Okay. Now, how far they are, meaning if you take an random number between let's say if you take a random number between 1 and 10, it might have the range of 10. Well, it's going to have a range of 10 because it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And so the variance will probably be somewhere around 5, because even if you take an average out of these numbers, it's going to stick somewhere around 5, 7, whatever, right? It's going to be 5.5, but who cares? But if you take a number which is between 1 and 100, there are 100 different possibilities. And so it is a very high variance from the average. It could be any numbers. So ideally, the average would be somewhere around 50, 55. But there's so much higher variance there. That's what variance is. Once again, I'm kind of butchering the concept of variance, but this is what it is supposed to mean statistically. Oh God, we have strayed so further away from what this was supposed to be. I hope you guys don't hate maths, but yeah, that's what variance means. Anyways, thank you, Sora, for that. Moving away from round robin, dynamic weighted round robin seems to account well for variance in both server power and request cost. But what if I told you we could do even better with a simpler algorithm? The algorithm is actually a very simple option, which is what we call the least connections load balancing. Now, least connections is actually super powerful. So you send requests to the server which has the least connections. That's it. How? So because the load balancer sits between the server and the user, it can accurately keep track of how many outstanding requests each server has. Then when a request comes in and it's time to determine where to send it, it knows which server have the least work to do and it prioritizes those. And that's it, right? This algorithm performs extremely well regardless of how much variance exists, right? Because we are still figuring out who has the least requests. So we'll just send them more requests, right? It cuts through uncertainty by maintaining an accurate understanding of what each server is doing. It also has the benefit of being very simple to implement. And that actually does matter. Let's see this in action in a similarly complex situation, simulations. The same parameters we gave the dynamic weighted round robin above. Again, these parameters are randomized with given ranges, so refresh the page to see new variants. Once again, this here we can see high variance request cost. We can also see high variance server power, and we can see randomization thrown at it. And we also have queues. So if you actually look at it, it's kind of doing a very good job. We are not doing round robin, but we are just sending packets wherever they are less of packets, right? So that's good. That's good job. While this algorithm is a great balance between simplicity and performance, it's not immune to dropping requests. However, what you'll notice is that the only time this algorithm drops requests is when there is literally no more queue space available. It will make sure all available resources are in use, and that makes it as a default choice for most workloads. Now, if you actually notice, it's a great point. Let me try to summarize it. So the only time a request will get dropped is if all of these servers are full. So for example, let's imagine first server, second server, third server, fourth server, fifth server, all of them are full. Okay. Now it will never send requests to those places because it will always try to send a request to the sixth server, which is kind of empty. The queue is empty. So it's going to send requests there, right? And if there will never be a time that the some server has an empty queue and the request was dropped, because if it had an empty queue, we would send requests there. That's what least connections mean, right? And so we can ensure that our 100% of server space is being utilized before we drop a request. And I know it seems like a very simple answer, but that is something that for me is kind of a very big deal. It's like, oh wow, that is a very simple solution, but it solves a very complex problem, right? Hopefully that is making sense to all of you. Can you guys just confirm if that makes sense to sense to you guys what I said? Like the server will only drop requests if it's in 100% utilization. That's it. Otherwise, it won't drop requests. Just drop a yes in the chat, hopefully. All right, perfect. Cool, perfect. Well, let's move on. I think the blog is still, we are halfway. There's more fun. Okay, optimizing for latency. Up until now, okay, see, the thing is, up until now, we were only kind of caring about, not dropping requests. But there's a more important thing, which is called latency. And sometimes it's better to drop requests and retry than to be stuck in the same horrible slow internet. Okay, I know a lot of people would rather refresh the page 10,000 times than sit through the loading bar, which kind of makes sense, right? So, up until now, I've been avoiding a crucial part of the discussion, what we are optimizing for. Implicitly, I've been considering drop requests to be really bad and seeking to avoid them, That's a nice goal, sure, that's a nice goal, makes sense, cool, whatever. But in reality, that's not what we want. That shouldn't be the metric, right? That's a nice goal, but it's not the metric we want to most optimize for in an HTTP load balancer. What we are often more concerned about is latency. This is measured in milliseconds from the moment a request is created to the moment it has been served. When we are discussing latency in this context, it's common to talk about different percentiles. For example, the 50th percentile, also called the median, is defined as the millisecond value for which 50% of the requests are below and 50% of the requests are above. I'll explain this in a while. I'll try my best to explain this. I ran 3 simulations with identical parameters for 60 seconds and took a variety of measurements every second. Each simulation varied only by a load balancing algorithm used. Okay, let's compare the medians for 3 simulations. Now, if you look at the response time, forget about the 50th percentile for like a few seconds, forget about it. Okay, now, so least connection one is the green line. We can see that it starts off horrible, but it kind of tapers off. If you look at weighted round robin, it starts off at 0 requests, like it starts off really good, but then it just gets horrible over time and it climbs up very high. And then we have the normal round robin, which is the 15th percentile one. It starts off very good, but now the response time is very high, right? Like you can actually see, because in least connection you might have seen, yeah, this is least connections. There will be requests which will take a lot of time, like more than 50% of the requests will take a lot of time because we are not dropping them as often. We will start seeing that latency build up. Okay, as for round robin, we will not see the latency build up. It's because we are just dropping extra requests, right? We are not serving them, so we are not counting them in our graph. So once again, this blog post, this explanation, it's not just good for load balancing, but it's actually kind of, explaining a lot of mathematics and statistics. I fucking love this. It's amazing. Okay. You might have not expected it, but round robin has the best median latency. If we weren't looking at any other data points, we'd miss the full story. Let's take a look at the 95th and 99th percentile. Okay, now this is what we are talking about in terms of most of the packets. Okay, if you only consider 50% of the packets, then obviously it's horrible. Then round robin is the best. Like, because it's, response time is very less, blah 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 blah, all of that shit. But if you consider all of the packets, even the dropped ones, you will start to see the full story. You can see round robin, once again, just ignore the 95th percentile and 99th. It will be one in the same thing for our purposes. So round robin is actually very high response time because we are not even factoring that the drop request will have to apply again. Weighted round robin is almost, it starts off horrible, then, it kind of tapers off. And then we have the least connections, which is kind of very similar with, with weighted round robin, right? We are not dropping requests, but at what cost, right? It's that meme. We have won, but at what cost? Well, latency. Note, there's no color difference between different percentiles for each load balancing. Higher percentiles will always be higher on the graph, blah, 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 blah. We see round robin doesn't perform well in higher percentiles. How can it be that round robin has great median but bad 95th and 99 percentiles? In round robin, the state of each server, once again, guys, pay attention. This is like the most important shit. In round robin, the state of each server isn't considered. So you will only get quite a lot of requests going to servers that are idle. That's how we get the low 50th percentile. On the flip side, we'll also send requests to servers that are overloaded. Hence the bad 95th and 99 percentiles. We can take a look at the full data in the histogram. So the histogram is going to make much more sense to you guys because you can see the highest number of requests, like, let's say the highest number of requests, they are getting served within that, 1 second delay. And then there are these rare requests. You can see these rare requests. Once again, it would be for round robin, they are taking so much time. Okay, you will never see a least connections or weighted round robin so far in the map, right? Like there are almost no requests in least connections which are taking more than 2 seconds. Okay, but in round robin, once again, you can see round robin is doing so well. If you're only seeing this much of the graph, once again, if you were only seeing this much of the graph, let me just hide it, kind of. So if you're only seeing this much of the graph, you would think oh my god, round robin is winning. Like round robin is doing so well, and everything else is like doing so low, right? Because oh, a lot of less requests I'm making it up till here. But if you look at the reality, the round robin is just not doing that well. If you look at the side, it has a lot of other pending requests. Hopefully, you guys can. Oh yeah, let my face was there. I just moved it. So yeah, round robin is not doing so well. There are many requests which are taking more than 2 seconds. Whereas you can see for least connections, you might see, oh, the blue one is, least connection never has like a very high response. It does not, but it has a stable one. And it has consistently been less than 2200 milliseconds, like 2.2 seconds, which is a good deal. It's consistent, whereas round robin is a very high variance. Okay, hopefully that made sense to you guys. If it did not, I would suggest looking at the graph again, because this is a very brilliant graph. Like this is how statistics, and this is what data science is. Hopefully you guys understand, because this is what happens in data science. There will be excuse me, n-dimensional data points, n-dimensional graphs, and you will have to do this sometime. So if you're interested in data science, this is what you'll have to deal with. I find it fascinating. Okay, I choose the parameters for the simulations to avoid dropping in requests. This guarantees we compare the same number of data points for all the three algorithms. Let's run the simulations again, but with an increased RPS value designed to push all of the algorithms past what they can handle. The following is a graph of cumulative requests dropped over time. So if you notice, least connection has the least drop request, then comes weighted round robin and round robin. Like if you keep on increasing, RPS, like on and on and on, round robin will drop the most of them. Okay, this is amazing. Okay, least connections, blah blah blah, depending on use case. Yeah, we don't care about that. One last algorithm. If we really want to optimize for latency, we need an algorithm type that takes latency into account. Wouldn't it be great if we could combine the dynamic weighted round robin algorithm with the least connections algorithm, like somehow, combine them? The latency of weighted round robin and resilience of the least connections, like best of both worlds. Turns out we are not the first people to have thought this. Below is a simulation using an algorithm called peak exponentially weighted moving average, or PEWMA. PEVMA, or whatever it's called. It's a long and complex name, but hang in there. I'll break it down how it works in a moment. Okay. So I've set up specific parameters for the simulation that are guaranteed to exhibit as expected behavior. If you watch closely, you will notice that the algorithm just stops sending requests to the leftmost server after a while. You can see this server is never getting any requests. Okay, it does this because it figures out that all of the other servers are just faster, and then there's no need to send requests to the slowest one. This will result in requests with a higher latency. Okay, if I send any request to the slower server, that's going to increase my latency. So I've just stopped sending requests to this specific server. That's what this algorithm does. Okay, now it's not, always, that it's going to leave out one server or two server. No, it's just to showcase that it will disfavor the servers who do not have a good latency. It will only try to send it to the servers who have a very good amount of latency, like very less latency. And also it will send to the server who have the least number of connections. So we're kind of now combining both of those things. So now we have the resiliency of least connections. That means we will not drop many requests, that because we are using 100% of the workload, most of it. And we will also have good latency because now we are also using the weighted round robin. We'll send it to the servers which are the most powerful, right? So how does it do this? It combines techniques from dynamic weighted robin with techniques from least connections and sprinkles a bit of its own magic on top. Once again, what I said. For each server, the algorithm keeps track of latency from the last n request. Instead of using this to calculate an average, it sums the values but with an exponentially decreasing scale factor. I am not going to explain what that means. This results in a value where the older a latency is, the less it contributes to the sum. Recent requests influence the calculation much more than the old ones. I don't know how to explain this to you, but yeah. If you do enough maths, I can promise you're gonna get it. The value is then taken and multiplied by number of open connections to the server, and result is the value we use to choose server where which server to send next request to. Lower is better. So how does it compare? First, take a look at 50th, 95th, and 99th percentiles when compared against least connections data from earlier. So we can see this red stuff, that's our PEWMA. And so far it's doing good. Like if you compare the first two ones, it's lower. Once again, it's lower as well. And if you consider it like the 50th percentile ones, it's still better. We see a marked improvement across the board. It's far more pronounced at the higher percentiles, but consistently present for the median as well. Here we can see the same data in histogram from. So I believe this data would make sense a lot for you guys. So we can see the red one, which is PEWMA, it's doing well even in like higher numbers in lower latencies. And also you can see it's not going that far as well. So if it's going that far, that's bad. You want to be concentrated in the first half, and you want to be higher in the first half as well. Like this specific part, you want to be higher in this specific part. Okay, I'll try to highlight it, but I don't know if the screenshot is gonna. Yeah, this specific part, you want to be higher in this specific part. If you're in this part, then you kind of already lost. You have high latency. We don't want that. Okay. How about drop requests? So we can see for PWMA, least connection still does better in terms of drop requests. So PEWMA might drop requests more than least connections because it's always a trade-off, right? So this blue line and green line, this orange line is kind of in the middle. So yeah, that's fine. It's better to drop requests sometimes than to have higher latency. It's completely fine. It starts out performing better, but over time it gets worse than least connection. This makes sense. PEWMA is an opportunistic, in that it tries to get the base latency, and this means it may sometimes leave a server less than fully loaded. I want to add that PEWMA has a lot of parameters that can be tweaked. The implementation I wrote for the post uses a configuration that seemed to work well for the situations I tested it in, but further tweaking could get you best results versus least connections. This is one of the downsides of PEWMA versus least connections. Extra complexity. Least connections was literally the most simple one, and PEWMA is the most complex one. Conclusion: I spent a long time on this post. It was, yeah, that's basically it. There's also a playground at the bottom. We can actually try out different algorithms. So we can just try out, PEWMA. If you increase the rate per second thingy, we can see that obviously it's dropping, but it's kind of maxing out. Let's use least connections to actually see that the requests are only being dropped when all the servers, I want you to notice this, when all the servers are full, that's the only time request will get dropped off. So we are using 100% of everything. Okay. Once again, the server power and request is like very low. We can increase the variance, and we can also increase the server power. And let's also increase the number of servers. So we can see until all the servers are full, they are not going to drop requests. So let's try to increase the number of requests, and we'll see what happens. Okay, we can see the only time we will get drop requests is like when everything is full. Now obviously there's like latency even in sending, so we are kind of hitting a limit. Like you might see something is empty, but trust me, the moment this has left, like moment one of those requests has left and something else got empty, we can't do anything. We have to go to that server wherever we were designed to go. So once again, that could be a limitation of the animation, but this is perfect. Okay, I'm gonna drop a link to this article for you guys. Like, check it out yourself when you have time. It's an amazing read. It's actually a very, very, very good read, and it makes sense. So yeah, drop a yes in the chat. That once again, I was not expecting even 4 people to stay. So whoever last 4 people are still here, good for you. I'm glad you if you got it. Please drop a yes in the chat if it made sense to you, because it's a lot of complicated mathematics, but it's fun. Okay, I'm gonna check off one thing from Obsidian, and that is load balancing done. Cool, you're good to go with load balancing. सभी टॉपिक्स कोडिंग में एक्सप्लेन होने चाहिए because coding has one meaning and set of words have multiple meanings. आप क्या सोचते? I mean, so you are you are you trying to say that this blog post should have been in coding terms, or are you talking about a completely different thing? Because I agree, coding is more implicit. Coding is more implicit in terms that whatever you say has only one meaning and there's very little room for error or misjudgment or misunderstanding. I completely agree with that. But as for making sense of something, you still would have to use words because I'm using words, right? I'm still using words to communicate with you. I wouldn't start speaking Python, right? I'm not Harry Potter. I don't speak the snake language or the snake language, whatever, right? I don't speak parcel tongue. Yeah, that's the word. So I feel like a lot of blog posts would still have to be in English. But yeah, when conveying certain ideas, I mean, I don't even know how you'd convert all of this into coding because you still have to explain what the graph is doing, right? You still have to use English words. Some paragraphs you didn't understand. Okay. Well, see, the thing is, if you don't understand something, I am what usually I understand from that is, and anyone I don't understand a lot of complicated topics, is maybe you just need to read it. Maybe there are certain gaps in your knowledge that maybe you are not still good at, and that's okay. And it's actually a good thing if you find out that you have gaps in your knowledge. I'm pretty sure a lot of people who left, maybe they had some work. I'm gonna give them the benefit of doubt, but maybe they were just not that interested. Maybe the moment math showed up, people were not that interested. People were very confused. Maybe people didn't like it. Okay, so that's always the kind of balance that you have to figure out, and it's a very good thing. It's a very good day, I would suggest, when you realize what you do not know. That is a very good day because now you can start working on the things that you do not know. You know what's the horrible part? A lot of people don't even know what they don't know. So yeah, and it's completely fine if you did not understand some parts of the article, as long as you had fun. That's okay. Cool. Yeah, makes sense. There is a supply chain attack that happens. So I'm gonna be jumping into that. If people have any questions or anything in the chat, please drop them. Whatever. Feel free to speak your mind in the chat. What I'm gonna do is I'm gonna jump to the next topic, and the next topic is basically about the supply chain attack that recently happened. I'll try to explain it, but I'm not gonna go that much into detail. I'm gonna wrap up excuse me, I'm gonna wrap up the live very soon, around 11. So we have like 10-ish minutes. So if you have any questions, drop down. Cool. Okay, so let's try and talk about the 100,000 websites that were actually owned. So let's talk about that. Uh, Not that. I could have just put uh, polyfill news, and that would have made much more sense. Okay. Let's pick up the article, which was like a really good one. Let's search it on Google. Yeah. Okay, let's pick up this one. I guess this one's the best one, I guess. No, not this one. Sorry guys, I'm gonna take like a few minutes to figure out where's that algorithm, not algorithm. Where's that article that I read in the morning? Uh, I think it was from Sansec. Yeah, this one. Okay, so this is the so what happened is recently there was a supply chain attack. Just to give you guys a gist, there was a supply chain attack which affects more than 100,000 websites on the internet. Some of the websites that are affected at the moment is literally like the big websites like Hulu, uh, Times of India, Times, New York Times. A lot of fancy websites are affected with this malware. Now, what happens is, and I'm gonna try to explain it. I'm not gonna go through uh, what like this. I'm not gonna go through like what this article is saying because it's more complicated. What I'm gonna do is try to show you what I'm talking about. So one of the websites that was kind of vulnerable was Hulu.com. Okay, so this is the website hulu.com. I hope it is still vulnerable because otherwise I don't know how to showcase. Uh, I think they removed it. Did they remove it? Let's check. I think they might have removed it. Polyfill. Oh no, they still have it. They still have it in the script, like at the very bottom. If you guys can see, that is like a polyfill script that we have. I'm gonna try my very best to give like a proper example. And let's take the page source. Okay, now this is basic HTML and JavaScript. Okay, this is basic HTML and JavaScript. Okay, hopefully you guys can see it. Now you have script tags. I hope everyone knows you have JavaScript inside like HTML. Okay, now script tags are there to actually run JavaScript. Okay, sometimes there are certain JavaScript which are not hosted on the website itself, but they are hosted somewhere else. Okay, they are hosted somewhere else. What do I mean by that? So let's try to find an example. I hope they still have it. Otherwise, I'll have to go find some other website. Uh, hmm. Do they have anything .js? Okay, so you can see at the bottom, I have. I'll do is I'll try to increase. Okay, that's not gonna help. Let me just copy the entire line, put it in Z, and maybe it's gonna make sense. Okay. So if you actually look at this, and if you just search for .js somewhere, okay, yeah. So what is happening over here is there are certain JavaScripts which you cannot just put in the same HTML because it's like too much. Maybe it will make it too cluttered. So what you usually do is you write the JavaScript, like you write the script, and then you say that, hey, whatever you want, like if you want this specific module, go to this place on the internet and grab it from there. Okay, this JavaScript is hosted somewhere else. You grab it from there and let's just use that. Okay, so that's how JavaScript importing works. Hopefully that's making sense to all of you. um Hopefully that makes sense. Okay, now what is happening is this module known as polyfill. Polyfill is a very simple module, and the entire point of this module is that there are certain websites on the internet which have a very high, which has a really good technology. Okay, that website is like very advanced, all of it. And there are certain computers on the internet which are not so advanced, which are not so fast, which do not have certain technologies. To make sure that they are compatible, to make sure that a very high advanced website and a very old computer, or browser, they're still compatible, the websites start using something known as polyfill. Okay, polyfill is a module. It's a JS script. You import it from other websites. So you import it from polyfill.io, right? It's a script, and it just makes a lot of high class features available to people with slow computers or people with old computers. Is that making sense, guys? Please drop a yes in the chat if that made sense. Polyfill is just a module that website makers, developers use to bring their website, which might have a very good, high level functionality, to also be compatible with people with low level hardware. Cool. Okay. Yeah. The only person who says yes, the first Akash, is like the dude with NPM, repositories and all that. Good job, Akash. Anyways, so this now the issue is if you're getting script from somewhere and if the script is malicious, you are basically giving that script full access to your web page. If you know this, that's one of the reason XSS is such a horrible vulnerability. XSS is such a it's actually a very good vulnerability in the sense that if you have access to the JavaScript, you can do anything on that web page. Anything. Anything from stealing cookies to redirecting them somewhere else to grabbing all of that data to even creating a botnet to even starting, a DDoS attack. Yeah, there are DDoS attacks possible just using JavaScript. It is possible, right? Now, what happened is, once again, we care about this one. What happened is polyfill.js was acquired by a Chinese company, and they also acquired the domain The domain actually, I'll just showcase the domain to you guys. The domain is polyfill.io. They acquired this domain, and there was something like static whatever .js, right? This is from where everyone would start grabbing that polyfill wala script. But what happened is that Chinese company for some reason grabbed this website, like this domain name. And what happened is once they got this domain name, instead of putting like the actual JavaScript, like they didn't change name. What they did is instead of this, they just started serving malware in the JavaScript. Right? They just started serving malware in the JavaScript. Obviously, it wouldn't be called malware.js. It would be called whatever the original name was. But this is what happened. All they had to do was grab the domain. They got the domain. How did they get the domain? I'm not gonna get into that. It's probably social engineering. But because they got the domain, suddenly 100,000 plus websites on the internet became vulnerable because they were using this polyfill module inside their website. And that's a real number. Trust me. Your favorite company, if I'm so sure right now that I'm gonna go to gujaratuniversity.ac.in. I don't even think that this website is advanced enough to actually use polyfill to actually work on lower end devices because it's already lower end devices, whatever. But your favorite website might actually still be using polyfill. Does Gujarat University use polyfill? No, it does not because they are so advanced. Does Parul University a website, whatever? I don't know if they use polyfill. The thing is, if you are that good enough, you will kind of have polyfill on your system. But it's a good thing to not have it because then you're vulnerable to the supply chain attack, which is like I just feel like you are suffering from success there. Why can I not see? Yeah, paid source. Let's see, polyfill. Do they have it? Wow, I did not expect that. Am I misspelling it? Am I misspelling it somewhere? I don't think so. Uh, Polyfill, yeah, that should be correct. Let's check if one of them, maybe for some reason, maybe I was misspelling it. Polyfill. Wow, I am surprised that they are not doing this. Cool. So ideally, please check your favorite sites. What would happen is they would have the polyfill extension, like the JavaScript on the website. And what would happen is every single time someone visits that website, the JavaScript can just steal data from them. And that is why this is a supply chain attack. This is not the fault of the web developers. This is the fault of whoever is maintaining polyfill. I don't want to blame them or whatever, but this is what we call a supply chain attack, and that's what happened, more or less, right? And somehow Gujarat University and Parul University are safe from it because they are so advanced that they were never using polyfill to actually help lower end devices. So yeah, that's more or less it. This is how the payload would look like. Instead of using Google Analytics, they would be using something Googie Analytics. Like if you look at it like very quickly, but yeah, they also own this domain, and they're just checking. Yeah, that's it. Now, what's the alternative of Polyfill? If not, why not we make it? There's an alternative. Cloudflare already came up with it. What they're doing is if you're using Cloudflare's protection, like if you're using Cloudflare's proxy, the moment someone enters, like the proxy, Cloudflare will automatically change the JavaScript of your web page. So instead of it using the polyfill CDN, it will automatically use the Cloudflare's version of polyfill, which is safe. So that's what Cloudflare is doing. I think that's amazing. So you can just say Cloudflare, yeah, automatically replacing polyfill.io links with Cloudflare Mirror. And that's their solution. So if you're using Cloudflare, they got your back. It's just like one option. Automatically replace insecure JavaScript libraries with safer and faster alternatives provided under CD and JS and provided by Cloudflare, blah, 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 blah. That's it. So yeah, that's basically it. Someone said check for GTU. Okay, good shot. I'm just gonna write GTU. Is it gonna even show up? Is it gonna say I was half expecting it to say, "Did you mean GTA?" But hey, whatever. GTU. Oh, there's a robot fest. There's a prize of 5 crore. Only if they put that money in the website development. But hey, what do I know? Poly. Well, yeah, no, guys. I don't think so. I don't think so. They use polyfill. They don't. They are advanced. They are too advanced. Do they even use any standard JS libraries? Yeah, they do. What? Okay, that is a JSP. I understand that. Why is it grabbing it from such a random IP address? Sorry, guys, we gotta check something. What is there on the random IP address? Why would it grab a JSP from there? For those who don't know, JSP is just like a JavaScript. It's a kind of object, kind of, you know, it's Java server page. So yeah, it's a kind of an object. Why does that exist on this random IP address? Yeah, I know, I understand it's not secure. Hold on, guys. I gotta check something really quick. What's going on over there? It's just because it's such a random thing to grab data. Like it's one of the drop down items. It's not even up. Is that it? Like it seems to be a drop down thing in research, and all of them are grabbing like the links are going somewhere else, right? So for example, women excellency and fellowship and whatever you may have. So like for example, this one goes to women in science or whatever, right? So that's one of the drop downs. Sure. What's this? Why would they have that? That's my question. Hey, you learn something new always. So yeah, once again, you can see the JavaScript has been dragged from like the assets folder over here. So, at least they're not grabbing it from elsewhere. Yeah, everything is locally made. Yeah, so all they are just using local JavaScript. That's really nice actually. You're making your own JS and you're just using that locally. So that's fair. You know what? That's fair. If you open it, you can see yeah, it's the whole jQuery. It's just JavaScript. But that's locally. If it's local, that's good enough for me. So yeah, once again, I don't think this is like doing something. Uh, live bug hunting. Yeah, I mean, I don't do bug hunting specifically, because we don't, we have views about bug bounty. But hey, whatever. Yeah, that's basically it. Hopefully, this made sense to you guys. So that was it. Like that is what we call like a supply chain attack. And it kind of was like a very big one. There are certain websites like I'm not kidding. Like the place that where I am working at the moment, they are vulnerable with like polyfill, and we actually just sorted it out in the morning. The moment I saw it, I highlighted it to my like the company person, and I said, hey, I think we are vulnerable to this, and we like fixed it. We fixed it in like an hour because it's important. I think it's very important. So there are many websites. Check out as many local websites as you can. I'm pretty sure they would be vulnerable to this. So that's good. It's gonna take like a few days for it to get fixed, but yeah, hey, that's basically it. That's basically it for this live. If you stayed till the end, I really appreciate. Thank you for watching. If anyone has any questions, comments, or whatever, we still have our WhatsApp community. Just drop them text over there. It should be fine. Also, I wanted to also announce the topic for the next skill builders. So we're done with S3. The next skill builders, I'm just gonna do the live announcement of the topic. So give me a second. I'm gonna scroll up. Also, people, if you're still here, if you do your own recharge for like Geo and stuff, yeah, Marvel Science will pick it up next time. We kind of are running out of time, but Geo has changed its plans from like they'll change it from like 3rd July. But what you can do is you can add existing plans on top of existing plans. So you can recharge with the older price. So maybe ask your dad, maybe if you are not, earning or whatever, ask your dad to recharge on top of the current recharge with the old price. And what's going to happen is, because you are also going to lose 5G functionality. At the moment, 5G functionality is only available to everyone who has 1 GB per day, 1.5 GB per day, and 2 GB per day, right? If you recharge right now, I did it. I actually recharged twice. So I am good for like 6 months with like the old price. I like spent like 1300. Uh, it's fine, right? And they stack on top. It's not कि एक साथ दोनों चालू हो गए. That doesn't make sense, right? So if you are a Geo user, I would suggest do it before it changes. I would suggest do it sooner, because Geo has removed a lot of plans from its app. They have started removing plans because they know people are going to do this shit. So whatever your plan is, I'm pretty sure usually everyone just goes with the 666 plan, like 666 rupees wala plan, because that's like the most optimal one. Go and do that recharge like a few times over. That's good to go. You can also use like a yearly thing if you want to. That's fine as well. They would have to honor it. I can guarantee you that, because that's a voucher, so they will honor it. I don't know if they're gonna honor the 5G thing or not, but they will have to honor the old price if you already buy the recharge. So do that. That should be a life hack for you guys. So yeah, while you do that, I'm gonna check. Yeah. So for the next skill builder session, we'll be doing Git and GitHub. So next skill builder, I'll roll out the Google Forms again. Once again, there are like 3 people over here, but whatever. I'm gonna roll out the Google Forms and check, like what skill you wanna go for. So as I said, this time it's going to be Git and GitHub. We'll start from Tuesday, and we have like 2 sessions, Tuesday and Thursday. If it's something high level, if we need to work more on it, I make sure, and then we jump to Saturday. Okay, that's basically it. Someone please clip this. So yeah, Sunny, we will drop badges. Okay, Sunny is as I said, he's our moderator slash the person who manages our social media and media stuff mostly. So yeah, there are also badges. So we'll be rolling out badges for S3. There are also badges for Git and GitHub. That's it. You will get badges when you are done, not right now. Okay. So yeah, that's it. I'll drop a link today. Fill out the form. Even if you filled it out for S3, you still have to fill it out this time. And please write why I should consider you for Git or GitHub. That's it. Anyways, thank you for watching. Good night. I'll see you in the next video. And I have to. Last time the stream went on for quite a long, so I'm gonna find the button to like end the stream, and I'm gonna do that. Bye bye.